Hello guys, welcome to this new series on my channel called Science in Minecraft. I'm going to be explaining some really cool wonders that I've always wanted to know, and I'm sure that everybody watching this really wants to know as well. Now the first one is gravity. Now people know what gravity is. People know that gravity is when something just falls to the ground. People have all heard of the story of Isaac Newton, of the apple falling on his head. Don't know if that's actually true or not, but it's a good example of how gravity works. Well, I'm going to explain to you in this video about gravity, about orbits of planets and how that all links to gravity, and also Einstein's theory of general relativity, which, if it's put straightly, is very interesting and not that complex at all. It's a really good idea. So yeah, we all know that gravity is when something falls to the ground, but that's the extent that some of people's knowledge only reaches to, whereas people don't know is that gravity is to do with the mass of an object. So the more mass an object has, the more gravity it has and the more gravitational pull it has. So if we go here, say the glass represents the gravitational pull that this object has. Because sponge has very low mass, you have to think of this as like in a space vacuum. Okay, so you can't think of this as actually on Earth. You have to think of these things as in space where no orbits are affecting it otherwise. Hello slime. Yeah, so sponge has hardly any mass, so it has quite a small orbit. And what this means is anything that drifts into this orbit, anywhere near it, that's in the vacuum of space, if it goes near this object and it's smaller than this, it will get pulled into the gravitational pull and start orbiting it. Now, something like obsidian, which is very big mass, if this was a planet the size of Earth, this would have a very massive orbit because it's got a massive mass. Massive mass. Yeah, so much more than the sponge, which has, air holes, doesn't have that much mass. Now, this here is a 3D diagram of our solar system, and you've probably seen this a lot before. So the sun is the biggest thing in our solar system, and because it's the biggest thing, and not biggest, well, it is the biggest, but it has the greatest mass also. So because it's got the greatest mass, all of the planets orbit it in nearly perfect circles sometimes. So Earth orbits around it because it's smaller mass than it, and the sun's mass is much bigger, so it goes around a similar orbit to this glass. Here's Mars. Mars is slightly smaller than Earth. We'll do a similar orbit but slightly farther away. And this is Jupiter. Now Jupiter is massive, but it's also made out of a lot of gas, so it doesn't have that much mass, more mass than Earth and Mars, so that would also have this orbit around the Sun. Now what physicists and normal people wondered before Albert Einstein came along was, why do they have this orbit? Why do planets orbit suns? Why do the things with more mass have a bigger orbit around and bigger gravitational pull? Well, there's a little thing that Einstein theorized, which is called spacetime. Now, you might have heard of it. It's basically saying that mass curves spacetime. So, if I just draw a little thing here with my glass, you have to imagine space-time as like material, let me just finish this. You have to imagine, so this glass is space-time. Now space-time you have to imagine as like a material or a sheet, kind of, or not not a 2D sheet, but just something that's there that we can't see, and mass actually curves it, right? Mass curves around space-time. So, no, sorry, space-time curves around mass, which is interesting. So, what this means is anything that gets caught in this curve starts falling into this curve in space-time, which means it orbits around it. So this is the same for the Earth and the Moon. The Earth curves space-time, which gives it a little dip, which gives space-time a little dip, which means the Moon is caught in the orbit and orbits around the Earth. So yeah, that's the basics of general relativity. So now you can go and say that you know about general relativity. Now lots of people want to know about black holes. Now, black holes is basically this theory of gravitational pull. Because it has so much mass, a black hole, its gravitational pull is so great that light cannot escape the gravitational orbit. So that's why it's called a black hole, because light cannot escape. So say this is a black hole, it would have so much mass that it would literally go so far that light could not escape, and light is the fastest thing in the universe. So yeah. But also people will think that black holes actually tear through space-time, and some people theorize that it ends up somewhere else. Like there's another side to a black hole, but we would never be able to travel through it because it would we'd just be spinning so fast. Because the fact that light can't even escape, we would never be able to escape because it would just be traveling so fast that, you know, it would end up, you know, on TV when there's like those when people enter like a I don't know how to explain it. In Doctor Who, when the TARDIS spins and there's that kind of whirly thing, that's like him travelling through space. Well, that's what would happen in a black hole, because it would be dipping so fast, the curve in space-time, and would be going so fast, our feet would we would literally stretch because our feet would be so far ahead of where our head is, because it's literally picking up pace that fast. So yeah, that's an interesting thought. Okay, so that's going to be this episode over on gravity and general relativity. Please in the comments say if you like this series, if you'd like to learn more about, you know, science, because I'm not a massive fan of science, but I just love this kind of like learning how the universe works, and that I think that's just amazing. But yeah, also can you tell me if I got anything wrong so I can definitely mention it in annotations, because I don't think I have got anything wrong, but I'm not that old, so you know, I'm not an expert. Okay, so thanks for listening. Thanks for listening to this first try of this first episode, and hopefully I will see you soon if you subscribe. So yes, see you later.